Okay, this is the video for Chapter 13, Section 1. So we are going to talk about translations and rotations. So this chapter is all about different kinds of transformations. A translation is kind of sometimes called a slide. It moves every point in the figure. It moves it in a plane in a specified distance in a specified direction. It takes a pre-image, that's the one you start with, and it slides it along a specific path, which is determined by a vector. A vector is basically an arrow. It tells you the direction it goes, and it tells you how far along that direction to go, and you get an image. So you can think about it like an actual slide, right? Except, of course, the kids probably would move, but not be congruent when they got to the bottom. But we can pretend. So the figure, the image, and the pre-image are congruent figures. And so the image of a line, if you have a line and you translate it, it will be a parallel line. So the translation and some of the other transformations that we're going to talk about are called isometries. And we refer to them as like a rigid motion. So it keeps the shape. It preserves length and angles and everything, right? Everything is preserved. So translation is one of the kinds, right? So moving A, B, C, D to A prime, B prime, C prime, D prime. So oftentimes we use the primes in order to show that that's the image of the other one. So in order to construct an image, we have to know what happens to a single point, right? So if we move, there's the translation, right? And this is the vector down here that tells us the direction and the distance, right? So it goes in that direction for that much space. Now, we can kind of look at it as like, going over 1, 2, 3, 4, 5 and down 2. And we can do that to every single point, right? So A is going to go over 5 down 2. B is going to go over 5 down 2. C is going to go over 5 down 2. All right, so the image of A, when it goes over 5 down 2, now is 3, 1, 2, 3, 4. So B, which starts out at 0, 8, it's going to go over 5. So now it's going to be at 5 and 6. And C, which starts at 2, 3, it's going to go over 5, making it over 8, and down 2, making it 1. That's a 1, not a 7. All right, so if you look at your first thing on your worksheet, I want you to draw the translation, right? So here's the vector that defines our translation, okay? And so I want you to see if you can draw the image of ABC using that vector. So go ahead and pause the video and do this one and the next one. Okay, so the each one is going to go down, let's go over 1, 2, 3, 4, down 3. So over 4, down 3. So from A, I'm going to go over 1, 2, 3, 4, down 1, 2, 3. For B, I'm going to go over 1, 2, 3, 4, down 1, 2, 3. That's B prime, that's A prime. And C, we're going to go over 1, 2, 3, 4, down 1, 2, 3. And here's our new triangle. And hopefully you did this one as well. But in this case, we're going over 1, 2, 3, 4, 5, down 1. So 1, 2, 3, 4, 5, down 1. There's going to be P prime. Q is 1, 2, 3, 4, 5, down 1. And R, 1, 2, 3, 4, 5, down 1. And S, 1, 2, 3, 4, 5, down 1. And you notice that the shape is preserved. It's still square. It's all of that, they are congruent figures. So in this one and the next one, you're going to go backwards. They gave you the image. You have to make the pre-image. And so you're just going to go backwards on the vector. Figure out where it came from, right? So see if you can do that. Put it on pause. See if you can do the next two problems on your worksheet. Okay, so if we're going backwards, we went down 2 and then backwards 1, 2, 3, 4, 5. So we're going to go over 5 and up 2. So 2, 3, 4, 5, 2. So my A was here. And B, so, and actually, if we wanted to draw this, once I find one of them, I can make the others in the same form. This is down 1 over 3. From here, we're down 1 over 1, 2, 3. So this would be my B. And it's still going to be the over 5 up 2, right? 1, 2, 3, 4, 5 up 2. There's my C. So there was my image. And the last one, I think you probably already have this one figured out. 1, 2, 3, 4. Oops. And 6. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So here's Z, here's Y, and this is going to go 2 over 1, there's X, and 1, 2, 1, 2, 3, 4, oops, 1, 2, 3, 4. Okay, so now we can also talk about the actual coordinates, and we can define it by that xy is going to correspond to some x plus a number. That was the shift on the x way, and y plus a number, right? So this is the way we often write it, with the arrow kind of means that moves to or translates to or denotes the new one, right? That's all right. So here we have we just have the definition, right? That I'm going to move, the x's are going to be adding 2, the y's are going to be subtracting 3. So 0, 0 is going to go to 0 plus 2 and 0 minus 3. And then 2, 2 is going to go to 2 plus 2 is 4, and 2 minus 3 is negative 1. So 4 plus 2 is 6, and 0 minus 3 is negative 3. And so you really are just adding to each of those coordinates according to what the definition was, right? So 2 plus 2 is 4, and negative 2 minus 3 is negative 5. All right, so this one is defined by a vector, but we haven't actually drawn the vector. We've just said that we've said that 0, 0 is going to change to negative 2, 4. And so over negative 2 up 4, it's this vector that's right up here, right? That goes over negative 2 up 4. But we can just look at that. We can rewrite this as our xy is now moving to x minus 2 and y plus 4. And I know that's what it is because that's what I did. I went from 0 to negative 2, so I had to subtract 2. I went from 0 to 4, so I had to add 4. So now fill in that chart on the other one and tell me what those coordinates are. Okay, I hope you got that. So 2, 2 is going to go to 0, and 6. 4, 0 is going to go to 2 and 4. And 2, negative 2 is going to go to 0 and 2. So sometimes we can construct a translation using just a compass and straight edge. So I made one. I found this really cool program where it shows compass construction. So I thought that turns out good. It's better than me trying to do it on a piece of paper while you're looking at through the webcam. So this is going to draw it out for you. It's a construction. I had to have it make, so in order for me to have it animate the whole thing, it's going to animate drawing the triangle and the vector as well. All right, so it's going to make a triangle that then I'm going to translate. Okay, so it was sort of this I had to sort of go between, is it going to draw too fast or too slow? And some parts you want it slower, and some parts you're going to wish it was longer. But all right, so this is my translation from D to E. So I know that I drew the whole line, but that's because I needed to make a parallel line to that. But D to E, that's the definition of the translation that I did. So what it's doing here is making a parallel line using the rhombus method, right? It just made 4 sides all the same length using that compass. So I draw a parallel line. Okay, so now I'm drawing a parallel line with through C. So I drew a parallel line through B. Now we're going to draw a parallel line through C. And then I didn't want to it takes a long time to do it, and it takes a while to watch it do it. So I just had it draw its own parallel line, which it did. So now it's marking. I don't know if you noticed, the compass came over here and measured from D to E, and now it's marking all those spots that same distance down the parallel line from A, B, and C. And those are my new line, my points. And so this is a congruent triangle. It is, every point has been moved the same distance along that parallel line. So that is how we construct a translation. Okay, so a rotation is another isometry. A rotation is a transformation where you have a single point on the plane that is your center of rotation. That point stays fixed, and it rotates the figure around it a certain number of degrees. And as we do it, if it's a positive number of degrees, that's the positive goes counterclockwise, and a negative one would go clockwise. So I know that seems maybe opposite from what you might have chosen, but there were other reasons. If you've had trig, then you would know that that's kind of a common thing that we do, right? So if we were in class, I would give you some tracing paper and you could actually do this. It is, you notice from that definition on the last screen, it's a moving, like we're holding the one point steady, but like everything else in the plane moves. And that's kind of like tracing paper, where you trace over there and then you move it, and you put a pin through that center of rotation, and you move it, and that actually moves everything, and you show that rotation. Yeah, I didn't. All right, so let's just examine for a minute this rotation. We're doing this rotation in 90, 180, and 270. And we start out with this ABC, right? So just think about when we translate, so from the purple to the blue, that's a 90-degree rotation. And the x and y values, they start, what is xy in the purple one, the first one, is negative yx in the second one. And so we're switching the x and y, but we're making the first one negative, right? So, for example, B is 3, 1. So I switch the 1 and the 3, and I make the 1 negative. So negative 1 up 3, that gives me my new B. And that's what happens when you have a 90-degree rotation. And you might be thinking about slope when you were in algebra and we did perpendicular slopes, and you had the change in y over the change in x, and a perpendicular one, you would flip the x and y and make it negative. And that's kind of what we're doing here. That 90-degree rotation does give you everything perpendicular, right? Now, if you go 180 degrees, that would be going over to the green one. Everything is negative. So for B, we go over 3 up 1, and here we go negative 3, negative 1. And for C, you go over 1 up 5, and here we go negative 1, negative 5. So 180 degrees just makes everything negative. And then the yellow one is a 270 degrees, or it would be a negative 90. And that, let's see, I think I was supposed to keep up here. That is, again, we're switching the x and the y, but now this time we're making the new y negative, right? So 3, 1, we're going to switch to 1, 3, but we're going to make that 3 negative, so it goes over 1, down 3. it would still give you that perpendicular, right? It would still give you, switch the x and y and make it negative, because one of them is negative, but one of them puts it over into the second quadrant, one of them puts it over into the fourth quadrant. And there was the 180. Okay, so it's an isometry, and in an isometry, things turn out to be, the circle turns out to be a circle, a parallel lines turn out to be parallel lines. So a triangle that's a certain shape is going to still be that same shape, but it might be oriented different after a rotation. So think about what it's going to look like. So imagine what it's going to look like here before I hit the button and make it move. Is that what you had in mind? So think about the fact that this line here, is going right to that B, and this line is going right to the B, right? So everything got moved. So this is a 90-degree angle from B to B prime. If I go A to A prime, it's going right down that diagonal, that's splitting that 90 in half and this 90 in half. That's another right angle. And if I did the C to the C, that's another right angle. So when you have a certain degree rotation, all the angles between the image and the pre-image are the same. It's that whatever that angle of rotation was. All right, so a rotation of 360 degrees, going to land right back on itself, right? 180, that's a half turn. And so we already talked about that it would be that flipped around, kind of like a, if you remember talking about odd functions, that's kind of what it is. All right, so on your worksheet, I want you to see if you can draw this. Draw all three of them. In fact, I think there are three of the triangle with the rotation given, right? So this is 90 degrees, so that means it's a counterclockwise. So put the video on pause and see if you can do all three of those. Okay, so let's try it out. So everything that's on this x-axis now is going to be on that y-axis. So this is my P prime, and 7 is going to be Q prime. And then this is going straight over to R by 1, 2, 3, 4. So that's going to be 1, 2, 3, 4. So this is going to be R prime. So there is my new triangle. Okay, now this time we want it to go negative 90 degrees. So we're going to go clockwise. And here's the center is around 0. So let's think about, it's the same distance away. That's A. So this, because this was right on that diagonal, then this one. So A prime is going to be right there. And let me get rid of those points. Okay, so B is right on that y-axis, so it's going to end up right on that x-axis. That'll be B prime. And then if you notice, this is negative 3, 5. Oh, sorry, 5, negative 3. So we're going to go over negative 5, negative 3. Oh, no, positive, yeah, negative 3, yeah, we say the same. Is that true? Then negative 3 over 5. Doesn't look right. Does it look right? F1, 1, 2, 3, 4, 5. Oh, I got these in the right place. A. Oh, no, it's down here. -5. 3. Sorry, it's going to be right there. Yeah. Got my 5s and my 3s mixed up there. Okay, this time we're going to go 180 degrees. So it's actually really going to flip straight through. So this will be right. This line here is still going to be, so this will be up to, this will be right here. It's going to go up to, sorry, went too far. There's the 3. There's the L prime. There's the M prime. And there's the N prime. Okay, so we can construct a rotation with other things. It gets really hard for us to do it on a graph or something with other than 90, 180, or 270. It's bad enough as it is. But you can construct one using the compass and we could do any degree that we know how to draw with a compass, right? So I'm going to make there's my center is at O, and then I'm going to make a triangle. And then what I want to do is rotate this 60 degrees. So what I'm doing is I'm drawing a circle, or a piece of a circle. I don't need the whole circle, right? For each one of those points with the center at 0. Now let me pause it for a second. What I just did, I don't know if you noticed that the compass measured from O to A and then marked that same distance off on that circle, the green circle, right? So what is created is an equilateral triangle. So that point, which he's going to mark here, that is an equilateral triangle. DOA is 60 degrees, right? So now he's doing it again and again. So each time, whatever the distance is from O to B, that's how far we mark it B on that circle. So there is the congruent triangle. We know that triangle ABC is congruent to triangle DEF. So the image of A has to end up on that circle. And the image of B has to end up on that circle. And the image of C has to end up on that circle. And that's how we construct a rotation. And every angle that matches the image and the preimage, the angle that through the center, so AOD, that angle will be 60 degrees because that's the rotation we did, right? And that means BOE is also going to be 60 degrees. And EOF, that will be 60 degrees. Let's back in here. I think we have one more thing. And actually, I actually didn't need to get back in there. I wanted to show you on GeoGebra. Do not lose my thing. Oh my gosh, why does it keep losing my thing? Okay, well, GeoGebra is really bugging me. So let me just go back to this and just show you what you would do with the construction. I didn't make it on the RoboCompass because I just didn't have time. It takes a long time to create those things. So let me just show you what happens the way. So when this one, I have the rotation, I have the image and the pre-image. What I don't have is the center. So, but what I know is that, just like we did before, this makes a circle, right? These two go through a circle with that center, so wherever that center is. So what I am looking for to show the center of the circle is the perpendicular bisector. So you know how to create a perpendicular bisector with your compass, right? And then we would have this one and the perpendicular bisector, and we would have this one and the perpendicular bisector, and those will all go through one point. And that is the center. So it's the perpendicular bisectors between the image and the pre-image that give you the center. And now when I want to know what the actual rotation was, then I could measure A, and the center, we'll call it O, A prime, whatever that is, that would be the angle of rotation. Or I could do B prime, and I would measure that angle. Okay, so you would just use a protractor to measure that angle, and that would tell you what that rotation was. But we can find the center of rotation by going through the perpendicular bisectors. So that's it for 13.1, the translations and rotation. So I'll see you in class next week.